In the previous video we learned how to use scatter plots and histograms. In this video we're going to explore how to plot the cross-correlation between two variables. If we have two different datasets from two different observations, we want to know if those two event sets are correlated. We want to cross-correlate them and see if they match in any way. We are looking for a pattern of a smaller data sample in the larger data sample. This pattern does not have to be an obvious or simple pattern. So we can use matplotlib's function from pyplotlib, matplotlib.pyplot.xcore. These functions can plot correlation between two datasets in such a way that we can see if there is any significant pattern between the plotted values. It's assumed that x and y are of the same length. If we pass the normed argument as true, we can normalize by cross-correlation at the 0th lag, that is when there is no time delay or time lag. Behind the scenes, correlation is done using numpy's numpy.correlate function. Using the useVlines argument, that is setting it to true, we can instruct matplotlib to use vlines method instead of plot method to draw lines of the correlation plot. The main difference is, if we are using plot, we can style the lines using standard line2D properties passed to the kwargs argument to the matplotlib.pyplot.xcore function. In this example, we will first import the matplotlib.pyplot module, then we import the numpy package. Next, we use the cleaned dataset of Google search volume trend for a year with the keyword flowers. After this, we plot the datasets and cross-correlation diagram. Then we tighten the layout in order to have a better overview of labels and ticks. Finally, we add the appropriate labels and grids for easy understanding of the plot. So, here is the code that will perform these steps. Here we used a real dataset with a recognizable pattern in it, two peaks repeating in a similar manner across the dataset. See the preceding figure. The other dataset is just a random normal distributed data of the same length as the real accrued data from the public service Google Trends. So, we plotted both datasets over the top half of the figure to visualize the data. When we're using matplotlib's xcore, which in turn uses numpy's correlate function, we computed cross-correlation and plotted it on the bottom half. Cross-correlation computation in numpy returns correlation coefficients array that represent the degree of similarity of two datasets. So let's now run this code and check the output. When you run this code, you get this figure on the screen. The cross-correlation diagram, i.e. correlelogram, tells us that the two signals are not correlated, which is represented by the height of the correlation. We see that there is no one vertical line that is the preceding 0.5 value. If, for example, two datasets would have correlation at a time lag of 100, for example 100 seconds shift between the same object observed by two different sensors, then we would see vertical line representing correlation coefficient x equals 100 in this preceding figure. Superb! In this video, we've successfully plotted the cross-correlation between two variables. In the next video, we'll learn the importance of autocorrelation.